think I accidentally closed the previous stream. Let me just post on Twitter real quick. The new stream. Okay. All right, so I was just saying that my friend Michiel informed me that he enjoys putting this on the background as ASMR. So Michiel, just for you, I put on a HackerOne t-shirt since we're squashing bugs today. So yeah, anything for my fans. All right, okay, let's actually get to it. Let's see, let's close up some stuff first. Right. Okay. I think we're good. Oh, I have to turn this on. Okay. Cool, so we have Xcode set up, and what I've done before is use the I've used the Xcode metal debugger. So that is what I want to try here. And I think what we can do is we can attach to an existing process maybe. So let's make sure that we have something running. Do we? Yeah, we have our example flame graph running. So let's see how this works again. So how do we do that? I think I've done this before. So let's go to src. Zaplib, target, debug, and then example flame graph. Okay, and then we do have to disable a couple of diagnostics. Yeah, because I think we're actually not properly adhering to the Metal API, so this would give us some errors. And I think these are right. Okay. Good. Let's make sure that you can all see this. Okay. And now what we can do is we can attach to a process. Or we can just start a new one. Let's just close this one up. And we can start a new one. Let's see, is this doing something? No. Oh, there we're going. Aha. Okay. Okay, so now it's starting the process. Okay, there we are. Now what we can do, I believe, is we can take a metal snapshot. So here, yeah, we capture a frame. Okay, yeah, we rendered a frame. So now we can look at some stuff, and this is quite fun, I think. So yeah, what do we have? So we have a couple of different things to look at here. This is sort of over time, a diagram. This is the memory that we have. And one of the things that you can see is we have a bunch of textures. I don't know why we have so many textures actually. I think that is a little bit strange. But, oh, because we have a bunch of different buffers, I think. Okay, anyway, that doesn't matter too much for now. Right, this is what we can do, we can basically look at the different commands that have happened. And there are different attachments and so on. And so somewhere here, there should be, right? So here you can see, okay, look, this is kind of fun. You can see the different ranges being rendered. So these are the glyphs. Haha. This is our depth buffer, which is not really that important here, but we have it. We could also remove it. We don't really use it right now, I think. Okay. So somewhere we should have an atlas, right? So this texture looks like it might be an atlas. Maybe not. Oh yes. Aha. Okay. So this is our atlas. The letters are upside down. And you can see the different colors, I guess representing the different MIP map representations. So that's fun. I wonder if we can just look at red, for example, if we can filter this somehow. Yeah, we can. So we can just look at red, and we can maybe... is there some way that we can just turn that into... oh wait, we can do it like this. We can set red to all of these colors, and then we should get, a nice grayscale here. Okay, so if you look at this does look a little bit better. This O is pretty clear, right? The K here is very clear. Yeah, all of these letters are much better than how we actually render them, I would say. I mean, what is this? Is this an O? That doesn't look as good. Are we kind of seeing total being spelled out here? Because that is the first thing that we do. Well, no, it should be to. Well, the A should be here because we shouldn't be repeating letters. So that is funny, but this looks to be a T again. Is that some sort of bug here? Can we flip this thing so we can look at it a little bit better? Is that possible? Flip the texture. Flip vertical. Haha. Okay, so now we look at the bottom here. That's pretty great. Total github.com/ and then of course our ... But why is it repeating these glyphs multiple times? That seems not right. Why are we doing that? Because this T also looks a lot better than this T over here. That is curious. I think that is most likely a bug. Yeah, here we have I and I again. That doesn't seem right either. We have two R's next to each other, in fact, and this I is like way worse. So not only are we repeating these things, they're also just not very good. Like there's inconsistency. Oh, right. I do remember something about this. I think, oh, this K is so good. Look at this K. This M is a lot better than some others. Yeah, I do remember seeing something about this in the code. Oh, this J is awful. This L is weird. Yes. I do remember seeing something like this before. Okay, so now we have something to go on. This is quite encouraging. This is quite encouraging. And it would be nice if we can just render this whole texture ourselves using some debug mode. So we might want to spend a little bit of time on that soon. Because that wouldn't be too much work, I think. And it would be quite helpful. Especially if we can have some debug tool where we can say like, oh, this is the T that gets rendered here, and this is the O that gets rendered there, and so on. If you can hover over it and it like highlights it or something like that, that would be pretty cool. Okay, let's get back to understanding the code a little bit better then. Let me just get some windows out of the way and move this a little bit over for myself. Okay. Great. So how does the glyph rendering actually work, right? So when here we generate our glyphs. And so we get the text style, we get a reference to this font's data stuff. So this function can actually be run in a different thread if you want, which we did at Cruise. And then this is the actual, we get an iterator over the characters. I did this the other day. Right, so we iterate over the characters. Oof. Okay. We get, right, so this is a little, we do some scoping here. So we can do some borrows and then let those borrows go. So we get a glyph ID, that's the first thing that we do. And this is something that I'm a little bit worried about already. No, okay, so this should be okay. At this point the font should be loaded. And we just have this map from character codes to glyph IDs, right? And from that point forward, we're just working with glyph IDs. But that doesn't mean that this glyph is in the atlas quite yet. But we have all of its metrics. So we have, the width to advanced width and so on. And then here we snap the width and height to pixel granularity. So this is what Forrest was saying earlier. This is hinting, essentially. Let me add a note. I think that this is the meaning of hinting, right? Let's see. Let me just do a quick Google search. Hinting, fonts, font hinting. Right, so we want to line things up. Right, so instead of this, you get this. Because this is properly lined up to pixel boundaries and you don't get these artifacts around it. So it looks a little bit clearer. Yeah. Right. So we do that. Snap width and height to pixel granularity. Okay. Right, so here we get the font size in pixels. Taking into account the DPI factor, right? So if you have a retina screen, it will actually align to those subpixels, or yeah, those sort of physical pixels. Right, so that is the difference between sort of a logical font size and a physical pixel font size. Okay, great. Okay, so this is the hinting of the width and height. Is that right though? That is interesting. Shouldn't that's kind of curious, right? Shouldn't in the atlas we already be kind of like the width and height should never be fractional, right? Because in the atlas we're working with whole pixels. That is a little bit strange to me. Do we have any notes on this stuff? Okay, these are just points. It's just, yeah. Okay. That is weird to me. Ha! And why is it not done in the shader? Yeah, why not indeed? I guess that we can scale the font a little bit, right? We have this. No. Okay, so my other hypothesis here is that this calculation is also being done when we generate the atlas, and it's just identical there. It's just an identical calculation that is duplicated. I was recently informed is how you pronounce it. Is this duplicated elsewhere? Because that would explain it, right? You do the same calculation in both places. But no, not right now. Or at least I can't find it verbatim. So let's see how we draw. We should be using this P max, for example, should show up here somewhere, right? Okay. Purely in the shader apparently. So there's this v pixel thing. Well, let's search for bounds then, perhaps. Okay. Right, so here it scales it in a similar way. We just do a slightly different way of dealing with this. We translate by this, and then we scale it by this amount, and then we translate it again. So, okay, sure, but we never do this transformation where we snap it to to a particular pixel size. That is curious, isn't it? That means that maybe this should already be an integer value. And then we also add 1.0. Like, what is that about? Why do we add 1 pixel? Okay, strange. There is so this is what I was thinking about earlier, the subpixel ID. So the strange thing to me though is that normally, I think if you're trying to do sort of subpixel rendering, you end up with different colors showing up, right? Because that's the whole idea. You kind of assume that the subpixels are kind of like laid out vertically, for example, in a particular pattern, and then you exploit that fact by giving things like slightly more red color or slightly more blue color if you want the pixel to be slightly more intense at either side. But why do we not see that if we then do things with this whole subpixel ID? Okay, anyway, let's keep going. Okay, so this I don't fully understand then. And then we do pixel snapping. What? Okay, so here we get some subpixel fraction. Yeah, I just don't think that this part makes that much sense. Unless we want... Okay, so I guess it is possible that we want to have like fractional positions, right? Like if you're animating a text and it's moving sort of over the screen. At that point, it is certainly possible to get sort of a subpixel. And I guess in that case you could kind of compute that. That makes sense. So in that sense, subpixel doesn't mean, oh yeah, I think I left a comment here somewhere. Subpixel. That this subpixel doesn't represent, doesn't have anything to do with like the red blue shift for text subpixel rendering, but just with the fact that you might want to render text not at a whole pixel boundary. So that by itself is not unreasonable. I do have some worries around that because you don't want to compute too many variants of each letter. So exactly how do we snap that is a question I do have. Like this subpixel ID, let's see. Yeah, it's not really bound in any way. It can really be anything. So let's see here. So yeah, in this to-do thing, right, we get these pixel fractions. Right, that is why there's also a Y subpixel, right, which you normally otherwise don't have, because that sort of accounts for subpixel shifts on the Y-axis. Okay, sure, fine. Yeah, and this might also have something to do with scrolling, right? If you're scrolling sort of at, not at whole, yeah, okay, anyway. Don't know if that matters, but Oh boy. Okay, so there's 64 possible subpixels, 8 in each direction. And they only use it for small fonts. Right. Oh there. Okay. 64 is quite a bit. That's okay. That's okay. We have room in our atlas. It's a little bit funky, but that's possible. Okay. Right, and then what they do here is they just... is that even right? Is that even right? This way... I don't... I don't think this computation is also quite right, is it? So... we take this fraction, we multiply it by 7... and then we cast it to an integer. That doesn't seem right to me. Like, shouldn't that be 8? Right, when the fraction is 1, which it should never be. That is when you yeah, this is not right either, I think. Okay. Okay. Yeah, that doesn't seem right to me. Okay. That still doesn't explain, though, why here we're getting subpixel shifts, because in our word total, if we look at our what we saw in the terminal, I don't think we ever had it shifted. Oh, okay, I'm not 100% sure about that. Yeah, I guess. Okay, so here, these. Okay, I think I have some idea of what is going on here. Yeah. Right. So that rectangle will always be snapped, as you would want it to. But sort of its logical position does not get snapped. So this advance variable doesn't snap. Yeah. So we probably have an advance width here, which is, yeah, some amount that we multiply by some amount, but that isn't guaranteed to come out to like a proper pixel boundary. Okay. Okay, so yeah, let's just make sure that we understand this properly. So we advance. Right, so here we generate the data for a single glyph, all of the dimensions, including all the subpixel business. And then we say, okay, we want to get this particular glyph. And then we'll have to see, does it exist, right? So if the glyph doesn't exist, we're going to push it. Otherwise, we just use it. We would push it to our atlas to do, so that would get rendered soon. And then, let's see. Yeah, then we actually generate it. And we advance x by the advance amount. Oh boy. Okay, so I don't know enough about Truetype fonts to really know how stuff like this is supposed to work. So maybe we'll have to read a spec. Maybe we will have to read a spec. Okay. Let's see. Let's do some Googling. So we want our Truetype font advance width. Is that a thing even? Yeah. Looks like there might be something like that. Pen. Okay, that's like. Okay. Truetype font specification. Okay, all right. Let's do some learning. Truetype fundamentals. Okay, let's read a little bit together. So this is talking about OpenType. Right, this is the part of the OpenType spec, sure. We're just dealing with Truetype fonts, but this looks like it might be a good overview. This looks like it might be good. Right, so Truetype glyph outline format, in which a glyph outline is described as second-order Bezier splines. Okay. So second order, I think, means like quadratic splines. Or, yeah. Okay, or maybe it starts with quadratic and then second order is cubic, who knows? Okay, whatever. When outlines are rasterized, Truetype hinting instructions contained in a font can be used to refine the rasterized results. Okay, this sounds very relevant to what we're doing here. In particular, the instruction set provides a powerful, sure, okay. Okay, so we start with the paper drawing. Great. And then the question is, yeah, how do we get back to paper? That is sort of the original use case of fonts, right? We didn't have screenshot maybe, or like, yeah. But of course, this also applies to screens. Okay. Right. Right, okay, so you first scale up your splines, and now we're thinking in pixel coordinates. And then we interpret it and we convert it to a bitmap. So, okay, so this is the scaling process. So now we're working pixel coordinates, yes. So this is sort of unitless, or like this f-unit thing, which is a particular unit in this whole Truetype world, I guess. Okay, so we have this, and now we need to execute instructions associated with a glyph and grid fitting. Right, so we have this thing, but we now need to modify it a little bit. And now we have a grid fitted outline. And then you rasterize. Right. And so this middle step is the step that we mostly care about. Once it's grid fitted, our rasterization seems to work fine. But it's really the grid fitting step that we are unsure about. And of course, the rasterization is a bit more sophisticated than this. It's not just are pixels turned on or not, but they actually have a value, right? So they can be partly turned on. Okay. Okay, so this talks about how to... Okay, let's just briefly check this out. Okay, so you can have multiple contours. Okay, so and they consist of straight lines and curves. And it has a handedness, right? So as you count from 0 to 1 and then to 2 and then consecutively keep going, on the right hand side you'll be filling it in, right? Okay. So it is a clockwise scheme, I think. Well, depends on how you define it, I guess. F units are font units. Okay, so this is where EM comes from. We have an imaginary square called the EM square. The dimension of the EM square typically are those of the full body height of the font, plus some extra spacing. Sure. Right, this is the body, the ascender plus the descender, and then some extra padding. Okay, fun. So the EM square, yeah, like things can just extend beyond it if you want them to. This doesn't look square. Maybe it's not an EM square but an EM rectangle. This one does look square. Okay. Okay. Okay, so yeah, you can choose your own grid. There's some limitations to the size of your grid, stuff like that. Okay, there's some conventions. Okay. Sure. Okay, so you can basically decide wherever you want to put it. And I guess later we'll describe exactly how to use things. Okay. Right, so you have F units or units per M. Okay. Right, so here we're going to convert to pixels, and there's like some magic number showing up now. And another magic number showing up now. So this explains why they show up here. We have a 96 and a 72 showing up here. Okay, that is something. Okay. Sure. Okay. Okay, now we get to the interesting part, the relevant part for us, grid fitting a glyph outline. Right, so here you get a bit of a distortion because the total width decreases. Sophisticated grid fitting. Okay. Right, okay, so there's an instruction set. Oh dear. Okay. Okay. So what I'm guessing is that what we're doing is using uninstructed. Oh no, it's a property of the font. Okay, sure. Okay. Wow. I had no idea that this is so sophisticated, like they said. Sure. Reasonable. goodness. Okay, then. There's like a whole thing. People write like a whole program. That is incredible. That is indeed incredible. Can we look at this stuff? Is there a really good like font debugging or like visualization program? Font visualizer. No. RoboFont. Okay, well now this looks interesting. Font Forge. Okay, let's have a quick look also how these things work. So we have Truetype from Apple. Okay. Yeah, that's the whole hinting language with a virtual machine. That does seem like a lot of work. What other types are there? Amazing. What a world. Sure. Let's learn a little bit more about that. Okay, so these are, sure. Okay. Okay, let's see. Okay, so OpenType is built on top, okay. So what can it do more? Colors, okay. Okay, so Truetype uses quadratic Bezier curves. The compact font format uses cubic ones. Okay. Let's also learn about WAF too. Web Open Font Format. OpenType or Truetype fonts. Okay, with compression and metadata. Okay. Okay. Right. Okay, so it's mostly for compression. Reasonable. Let's just learn a little bit more. Oh dear. This is not very good. Sure, let's learn about this. This is because I unplugged my monitor earlier. That's funny. Okay. That's funny. I see. Okay, so OTF is a bit more restrictive and TTF is like this full interpreter thing. Okay. Okay. Right. Okay. People say Truetype is going away, hinting is going away because we get like these insanely high resolution screens. But we're not quite there yet. Not quite yet. Okay. All right. That all roughly makes sense. Okay. This is what we want. Oh man. Wouldn't it be cool to run this in the browser? Okay. Debugger. Let's see. Security. Beautiful already. What a it's a splash page. Remember splash pages? Unbelievable. They're still with us. Yep. Okay, so let's try the Ubuntu file first. I'm just curious. Man, we should have a Zaplib version of this tool. Right. So a bunch of things are just not there. So a bunch of things look like they're spaces or something. Okay, here it shows some Unicode information. Yeah. Yeah, okay, so this is sort of the whole font. This really has like everything in it. Lots of Chinese characters, Korean, all sorts of silly stuff here. Man. Okay, so this is a complete font. Okay. Very interesting. Let's look at the T, for example. Let's see what we have. So there's glyph info. Right. Okay, no. Sorry. There can be comments in here. Colors, positionings. What is this? No, nothing. Nothing here. Look up. Okay. Aha. So here it says for oops, what did I do? So here it says that for case-sensitive lookup, you can go to T. Right, great, very, very helpful. That's great. Okay, there's nothing here, no ligatures. Okay, nothing really, not too much here. What else is there? Transform. Okay, no idea, cancel this. Expand stroke, ooh. Okay, where is it? We need to zoom out. Oh, here. Where's our friend the T? Can't be found. Or is it like super zoomed in? Like at the origin or something? No. What? Okay. Nothing to see here. Okay, what is that? I see. What are we looking at here? What are we looking at? New outline window. Oh, okay. Now that's more fun. we have ourselves a T. So these are the straight lines, and then here we have the Bezier curves. That is fun. Sure. No idea what any of the... Oh, this is the mouse interaction or something. Oh, this is if you hold control, like what it will do. Okay, fascinating. This is pretty interesting. Okay, so now let's see. Okay, so edit instructions. Oh my goodness. So these are the raw hinting instructions. So incredible. Okay, so it actually has a bunch of instructions. Amazing. I just don't really know what the source code is. This is just like the assembly code. What happens if we click parse? Okay. Okay, sure. So that's a different representation. Can I make this bigger? Yes. Okay, sure. Okay, it's just the same. Very, very helpful scroll bar that doesn't go all the way to the bottom. What does this say if we hover? Sure. Wow, I'm learning so much. What an interesting thing. Okay. Okay. FontForge could be better, it says. What? Okay. Okay, so now we're going to grid fit. We want probably to do the grid fit live update. Okay. Oh, I see. I see. So we can do, let's see. No. What was that? On the keyboard. Equals and minus with option, it looks like, but maybe not. Okay. No. 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 That doesn't seem to do anything if I press the keyboard like that. It does seem like that should do it, right? Just mashing all the keys on the keyboard, see what happens. Different combinations. Unclear. That would be fun if we could. Yep. Right. What is this? Oops. Now we're gone. Okay, let's start that over. Okay, so it's a little bit hard to see, of course, what exactly happens. Like, how does this get grid fitted? Okay, so that is a T. But then if we disable the instructions, oh, there's no instructions. Okay, so this is what it looks like if you don't have any instructions. Well, let's not save this. Let's see what it looks like with instructions. Oh boy, do we have to do this again? Okay. Where were we? Okay, so now we have instructions again. Okay, yeah, so that looks a little bit different. Maybe. I mean, this looks fairly similar to what we had before. If we now remove the instructions, say bye-bye. Okay, so not much changed there. Okay, so unclear what those instructions do. But it's clear that there are instructions, and maybe, yeah, I also don't know if this tool properly uses the instructions or not. So I guess we can open the other one, see what that looks like. Okay, so here we have a T as well. There's also instructions here. Oh, we have a metrics window. Advance width metrics. Right, so we have this width and a left bearing and a right bearing and a kern. What if we go to like M? Ooh, I see. So for a monospace font, this will all be the same. But you might, I guess, for the other font, get something different. So let's see, what did we do? Metrics. So here, if you okay, so it could kern this a little bit better, maybe, or like FI. Oh no, wait, we're still in liberation mode now. Wait, where were we? This is Ubuntu. Okay. Look at this. It makes it into a ligature. So now we get a single glyph here. That's cool. That is pretty neat. That's also ligature. FF. Right, so if we have we get a kerning value here. So otherwise it would be right. That's cool. Okay, that's not a kerning class, because otherwise, if we wouldn't have this, there would be too much space there, right? Right. Okay, so I doubt that we're doing any of these things today. Which is fine, I think, for the types of applications that we're primarily interested in. We're not doing long-form documents or anything quite like that. So we just need to support the basics, and it needs to run very fast, right? Like that is what we are concerned with. We don't have to have like perfect typography for, the few labels that we have. And we could give people the option to opt into a more sophisticated renderer if they care more about that than about the performance in the future or something. But I'm just trying to understand this stuff right now. Okay, so there's a lot of interesting things happening here already. These things are fairly advanced. Sure. Okay. So I would assume that what we're doing is we're just, getting the most basic values out and trying to use those. This still doesn't completely explain to me, like, what happens exactly in terms of advancing widths, in terms of subpixel snapping. In terms of grid align. Okay, so let's maybe do a quick search for that. Truetype advance with grid align. Mm-hmm. Because one thing that I could imagine is saying that the advance width should always be a pixel integer. I could also imagine keeping it fractional and then saying, but then we round the letter to a whole integer. Both of these are pretty big choices, though. Okay. Interesting. So for hinted glyphs, the advance gets grid fitted itself. But of course, that is sort of dependent on the program that you run. Mm-hmm. I mean, this is for free type, so it's a little bit different, but sure. It seems reasonable to try, at least. What I don't understand, though, is this one. Oh no, this does look pretty good, relatively. Okay, so we could try make it like grid fitting the advance width. That is one thing. Let's maybe first print some more values again, because we have a slightly better understanding of everything right now. So one thing I want to print. Well, first of all, let's just only print stuff when we are. Let's get this back here somewhere. Let's only draw when we're drawing the word total. What is it again? Span.label equals total. Okay. Yeah, we can also, we can keep it open, that's fine. Okay, so now we just get the word total in here, and we get the information for that. Great. Sure, yep. So now what I want to do is I want to also log the advance width, or just in fact most of these metrics. Right. Can I do something like this? Is that okay? Just happy with that? Sure. Okay, that's pretty nice. Let's maybe do this. Okay. Cool. So we have the T, which indeed has a fractional advance. It also ends up with a subpixel fraction itself, but that is so strange to me. That does not make that much sense to me. Why is that? Because isn't its position... Like, let's also print the current x. And sure, the char offset, yeah. Because we start x... Or do we... Ooh, we might not... Okay, okay. Well, let's see that first. We might not be aligning that, actually. I don't think that there's anything. Okay, no, we do align it at 2. Right, because it's the very first one. Like, maybe for this one it shouldn't be aligned right now, but for the first one it very well should be. So then why does it get a subpixel fraction? Right? If it's going to be drawn at a integer position, that is strange. And then of course now we are dealing with fractions for sure. That is very logical. Okay, lots of questions here. Lots of questions. So let's dig in to the very first one. And boy, do we need to unit test some of this stuff. Okay, so the first one is, why do we have such a strange subpixel x fraction and y fraction for that matter? Like, why do all of these, like, we're not even moving y here. Okay, so how does that work? What? I mean, DPI factor is still the same, right? Like, let's also print that for good measure. That should just be 1. Yeah. Okay, so let's maybe... it would be nice if we can just step through this in a second. We can run a debugger in a moment. Let's just... let's maybe do that, actually. Oh boy. Yeah. So we want to add, because we added an example. What is our example? Oh yeah, example flame graph, which comes after charts. So charts, we'll add an example flame graph. Okay. So let's see if our debugger works. I haven't tried that on this machine yet, I think. Great, great. So where were we? So essentially what we want to do... Oh, I also get this. Okay, great. Okay, yeah, let's get rid of that. Right, so we want to set maybe some breakpoints here, right? We want to set some breakpoints here. Let's set a breakpoint here. Okay, so we're now at the letter W, presumably. Yeah, W here is T. And then our subpixel fraction for some reason is that. And so we get a minimum position here. Oh. What? Is it because this thing is... Okay. Sure. This one needs pixel snapping. Is that a to-do from Rick? Is this to-do, Rick? This one needs pixel snapping? No, I don't think so, right? Wait, I'm still a little bit confused. Because we've learned that these bounds are completely arbitrary. From what I understand. Okay, well that's fine, I guess. So I guess you can get a subpixel fraction that is not 0. Even if you are, and then it will still generate a letter that looks like it's sort of properly, or mostly properly aligned there. Okay, so I guess that is fine. Okay, this will need a lot more comments. Yeah, and also its representation there. Like I don't like that. I don't like the fact that subpixel fraction is non-zero when we are actually grid aligned, right? Because now, yeah, that just seems confusing to me. Let me add a note. Confusing. That's sure are not 0 even when exactly the glyph is not subpixel shifted. Amazing, Copilot. Amazing. Okay. Yeah, and it does seem strange to me. Yeah, this is not right, is it? Because we are flooring this stuff. So we are trying to kind of align this number in some way, right? We get like this fraction here. And then, yeah, I can't reason about this properly in this way. It's like we then multiply that by 2, for example, if you do have that DPI factor, and then we floor that, but the thing to begin with doesn't have. Like, okay. Like this, with this floor, I can't really understand how that is supposed to work. It's like here we are pixel aligning it. So this one is where we get, yeah, okay, I see. So this one is pixel, is where we pixel align it, and so then here we're saying like we'll take the difference of, yeah, okay, sure. Yeah, but the thing is, yeah, okay, that kind of makes sense. So then here we do snap it, and we get like actual 2 and 51, sure. Okay, so then we want to say let's maybe also snap advance. How do we do that? We can round it up, we can round it to the nearest, something like that, right? Yeah, we only really use advance. Okay, sure. What if we then say that we want to round it, right? What if we say like round here? Is that going to, yeah, maybe something like that, honestly, but we need to figure, yeah, it needs to take account the DPI factor, because we don't need to, but in our case, right now it's 0 anyway, it's 1 anyway. Okay, so let's run that once more. Okay. This does look a bit better, doesn't it? Like the T's are the same now. The A is still weird. The L looks better too. It is weirdly Y-aligned. Like it looks like it's not properly Y-aligned. Oh, but that is possible. We might just not be passing in a proper Y here. Yeah, let's run it with this again and see what is the Y. position actually. No, it is properly Y-aligned. And what did it look like here? Yeah, here it also looks weird, right? It looks like it's not properly Y-aligned here either. Like sort of all of its bottom lines, all the horizontal lines seem to be pretty aliased. Like no matter which one you pick. And that might just have to do with the font height or something, right? Like this is something where I would expect the font instructions to really help quite a lot. The hinting instructions inside the font, right? Because you don't always know exactly like where to put these lines otherwise. Yeah, this is funny. It does look a bit better though overall, it must be said. So is this one of those cases, like let's see, what if we just offset it by a little bit? And this is pretty silly, but let's just try it out, just to see what happens. No, wait, where are we here? What if we offset it by 0.5? Right, the text. Much better. Much better. Wait, I closed the digital color meter. Oh, this is so much better. Yeah, this is a world of difference, right? Fascinating, okay. So it can't do this stuff automatically right now, which is a bummer. So let's see what happens if we now bring back all the labels. Yeah, so now these are probably offset weird, at least potentially. So if we now round this number here, if we say round here, and then also, well, we already know that this is, yeah, but just to be sure, we can do something like this, right? Oh my goodness, this is so much better. What a world of difference. Yeah, you do see these get very close to each other here. So I do wonder if we should have this advance be like sealing. Whoa, that also makes a big difference actually. The debug logging is really slowing things down now. That looks quite a bit better, I would say. But I don't know if it should be the default necessarily, right? I'm also curious if we go back to our fonts, because we did some overriding here. If we just restore that all the way back. So here we have a brightness and the curve is different and so on. Actually, let me look here. Okay. Yeah. Okay. Okay, this just looks very silly now. Right? It just looks like they're just messing with us. They jump around a bit too. Why is that? I guess that makes sense because we always align everything now on whole pixels. Okay, let me get rid of some of the debug stuff real quick, because that's just a little bit annoying at this point. Yeah, so you get these annoying jitters now, because, you know, we have introduced some non-linearity. And we get some rounding errors, I would guess here. Yeah. That is fascinating, though. Like if we put this back at curve 1. Yeah, they at least don't look so silly anymore now, which is better. Sure, okay. I'm also curious what happens if we use the normal text style. Yeah, that looks weird. I mean, that might still be this also. That looks different. What if we get rid of the advanced again, just to see the baseline here? Right, and then also if we disable this rounding here. Maybe even this part. Yeah, this font just in general looks a bit better than the other one. Yeah, this just in general seems to just render a little bit better here. Like, yeah, this can't be a coincidence, right? I mean, here it gets a little bit blurry. It's not too bad. Yeah, on the whole, this font just renders bit better. And then let's layer in our optimizations again, right? Like so, the first letter should get a little bit better by doing this, right? By rounding to x. Not that much actually. That doesn't seem to help for those letters. Yeah, maybe a little bit better there. No, wait, that is weird. This R is different than this R. That shouldn't be the case if we're rounding them in both cases. That seems wrong. Okay. Ooh, we're also doing this anchoring. That might also introduce some issues, like the 0.5 issue. That is interesting. That is strange. Yeah, I feel like we need some sort of text atlas debugger for this kind of stuff, maybe. Like, how is that possible, right? How is it possible to get like a different R here versus here? Very different R, and this one is different yet again. Yeah, that doesn't seem right. I think that there's more going on here. Let's see. R and char offset is 0, then we're going to debug print this again. Yeah, what? What? Huh? I thought we were rounding. Oh, God. Haha. Oops. Yeah. That is not gonna work. Okay. Okay. Let's give that another shot. Let's do it like this. And then we can round this whole thing. Ooh, look at how sharp those R's are. My goodness. Oh, that is so good. And then the rest kind of gets out of whack. A little bit, not too bad. Let's somewhat. The bottoms of these things are also still a little bit weird. Maybe that is also... Okay, what if we don't do this anchoring like this? So we know that that is a whole... yeah. Okay, the bottoms are a lot better now. Not that much. Doesn't make that much of a difference. Should we also round this whole thing, just to be sure? Okay. That's still a little bit weird there, but not too bad. I think we can bring this back, honestly. Yeah, this looks pretty much the same. Yeah, this is decent, right? This is decent. Now if we bring back the advanced rounding, what does that look like then? Yeah, the widths just become a little bit weird, but the letters are quite crisp. It just looks funky, right? The letters are very crisp, but the positioning seems off. Let's do that back. Yeah, this just looks a little bit more natural. Yeah, and it doesn't jitter too much anymore. Like this total thing stays basically in place. You don't really notice. Yeah, you do notice like the text jittering a little bit compared to the... Right, you can do this. Well, that seems all pretty much fine. Yeah, this looks so much better. Now I'm curious what happens if we go back to the monospace font now that we fixed this rounding issue. Not bad. Oh yeah, we do need to do that half. I think that will look better. Yeah, that looks quite a bit better. Yeah, that's good. I like the L right now. Okay, so now if we do the advanced width, because it's monospace, right? It should be sort of consistent now in how much more you get, how much more space. Huh. This M looks weird. And it does look as if it's still a little bit out of whack. What What if we do something like this? Yeah, this is now all becoming quite silly, isn't it? Like, let's look at the baseline again. Right, so we really actually just want to move them all a little bit down. So maybe like plus 0.2 or something. Maybe slightly further down. Yeah, something like that. But the M, yeah, that is still a little bit weird, isn't it? But it's maybe, are all the M's like that? Oh, here we have a .com. Yeah, they're all like that. So it's, yeah, I mean, this is what you get for just not having proper hinting, I guess. It just doesn't know how to align these things properly now. Yeah, if you had like a proper hinting system, it would sort of figure out that it falls right in the middle here and that you want like some characters here, for example. Yeah. But it's not bad. It's not bad. I do wonder if there's some sort of standard fonts that we could use that just have sort of or we could even do this ourselves. We could have sort of proper pre-computed stuff. Yeah. I mean, this is not the worst. I do think I like it a little bit better to have it like this. And I think, isn't that also what's Pyroscope? We still have that open. Yeah, it doesn't look like a fully mono. Is it monospace? I can't completely tell, actually. It does look monospace. But in our font renderer, I do think it looks a little bit better. To have it not monospace. And then to also, I think, disable the advancement thing. The advancement rounding. We should also make the font just a little bit bigger, I think, just in general, to match what we have there. Like that by itself might also just help. Okay, I think I'm going to call it there. I am getting pretty tired. I'm going to take a little break, and maybe I'll stream some other time, maybe this week, maybe next week. We'll see. In any case, thanks so much for joining me. I hope this messing about with fonts was entertaining. Alright, see y'all.